Hi, this is Mrs. Ziegler, and I'm going through your acceleration notes. So from your reading, and your notes from before, you should know what acceleration is. Acceleration is a change in velocity. So remember, what is velocity? Velocity is how fast an object is moving and in the direction that it's moving. So when they have a change in velocity, that means I'm speeding up, or I'm slowing down, or I'm changing direction. That means I have acceleration. So the equation for calculating acceleration is final velocity minus initial velocity divided by time. The units that you need to know in order to solve these problems are the following. So your VI, which is your initial velocity, again, velocity is distance over time, so it's meters per second for the SI unit. For your final velocity, it's the same units, meters per second in this case. Then you have time, which of course is seconds for the SI unit. And then when you plug in all that units and you calculate it, then your acceleration units are meters per second squared. So for these note sheets, you're going to get this information and you're going to do the practice problems on your own. I'm giving you another sheet or 3 practice problems that you are going to put into your notebook. If you are not in class to take these to get this paper, then I would just highly recommend you just write the practice problems in your notebook. Either way, you will have these problems for you to reference when you take your quiz next week. So we have our first problem, which is a car goes from 25 meters per second up to 30 meters per second in 7 seconds. What is its acceleration? So again, when we're solving problems, the first thing you have to do is be able to identify your knowns and unknowns. What have you been given? What are you solving for? Then when you have that, then you are going to have your formula. You write your formula out, and then you plug in all the knowns into your formula. Chug means that you're going to solve the problem. And then in the answer part, that's where you're going to put your answers with your units. Regardless of where you're putting all your things, you always have to have your units. And when you do not, you will have points taken off. So again, we know the formula for acceleration is final velocity minus initial velocity is equal divided by time will get you acceleration. So first thing that I've been given is 25 meters per second. Then I've been given 30 meters per second. The way that you recognize which one's initial and which one is final is based off of the wording. It says a car goes from 25 to 30. So that means your initial velocity is the 25 meters per second and your final velocity is the 30 meters per second. Then 7 seconds, of course, is your time. So then listing your knowns, and then your unknown is what you're solving for, is acceleration, which your units should be meters per second squared. So then you have your formula. You plug in all your knowns into your formula, and then you solve. So we take 30 minus 25, which is 5 meters per second, divided by 7 seconds, which will give me 0.71 meters per second squared. Again, if you show me all this work and your math is incorrect, I will still give you full credit if you have everything that I'm showing you here. If you do not, then you're going to lose points. All right, next question. I have a plane that lands on an aircraft carrier. It is initially traveling at a speed of 75 meters per second. After landing, it comes to complete stop after only 2 seconds. Calculate the acceleration. So the first one is meters per second, 75. That's given first. Then it says it comes to complete stop. That is my next speed. And then I've got, because of the way it reads, my initial velocity is 75 meters per second. My final velocity is the complete stop, which would be 0 meters per second. And then the time, of course, is 10 seconds. So again, I'm listing everything that I've been given. I'm solving for acceleration because that's what the question asks. I have my formula. I plug everything in. Then I solve. So again, it's 0 minus 75. So that's going to be negative 75 meters per second divided by 2 seconds. So therefore, my answer will be a negative 37.5 meters per second squared. So again, here you see that I have a 0 for one of my speeds because it is something that's coming to complete stop. Another way that you would see a 0 would be initial if it starts from a stop to accelerate to going to a different speed. That would be acceleration. All right, the last problem that we will be doing on your sheet is this one. I have a car that starts from rest, meaning it starts at 0 meters per second. It accelerates at a rate of 7.3 meters per second squared for 13 seconds. How fast is it going now? So again, I have rest, which is starts from, so that's my 0 meters per second. Then it says accelerates at 7.3 meters per second squared. Again, meters per second squared tells me that it is acceleration. Then I have 13 seconds, okay, as my time. So again, it says starts from rest, so that's my initial velocity. And then I've got time, which is 13 seconds. And I have acceleration because I have meters per second squared. So therefore, I'm solving for my final velocity. So again, these are my known and my unknown. I have my formula, and I plug everything that I've been given. So here you see I'm solving for V of f. And V of f minus 0 makes V of f divided by 2 seconds. So if I'm solving for that, I'm going to multiply the 2 times the 7.3 to get my 14.6 meters per second for my final velocity. So again, I'll show you mathematically what you're doing. So again, I have V of f minus 0 meters per second. So that's V of f. And I get rid of the 2s since I'm having it divided here. I'm multiplying it by 2s on this side, and I'm multiplying it on this side. So my V of f is 14.6 meters per second. So again, if you have any questions as to how to calculate, I would review these notes or ask questions in class.